The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. Welcome to the EasyPower Tuesday refresher. Those of you that this is your first time, we try to conduct a refresher webinar in this time slot twice a month. And so I invite you to join us whenever you're available. You're welcome to contribute to the discussion by submitting questions or comments during the session. And today we're addressing a topic, while less technical, goes to the usability of the study after it's been completed. Our usual habit is to start each session with the poll question, so I invite you to participate. And here's the poll question for this week. So how large are the projects that you undertake primarily, usually, on an average? So if you would indicate what your preference or slot would be. No obligation, obviously, in providing this feedback, but it does help some of our discussion to focus on the topic in the areas that are most attended for. Looks like we have a quorum. Let's give this about another 10 seconds. Thank you. So here's how people have weighed in on this. It looks like fairly normal distribution as far as a 3-topic distribution can go. And then the second question is, how often do your studies include redundant or cross-connected systems? Again, both of these questions go to the need or some possible ways to improve larger one-line diagram construction. Frequently we get studies in or copies of one-line diagrams where people have inherited the project and it's huge, and one of the common questions is there some way to kind of organize this? And so that's why we're presenting this material today with some ideas towards that end. So it looks like people have weighed in evenly, and there's where categories fall here. Okay, apologize for the lack of specificity. I think this quote is attributed to Abraham Lincoln, but the adage is, give me 4 hours to chop down a tree and I will spend the first 2 hours sharpening the axe. And the bottom line is the time spent planning the layout for my large project will pay off with a better study in the long run and consequently better utilization. Doesn't necessarily change the results as far as the analytical calculations, but it does make it help anybody following on your path to utilize the data or the database after you've developed it. As I indicated, there's no hard and fast rule on this topic. The real payback, frankly, is from an arc flash study in general is the application of the results. In other words, a better understanding of the existing hazards, a more in-depth discussion about the need for hot work, how to do it more safely, and often better training. An even larger potential is possible in the form of benefits from further analysis of your system. This could be understanding load distribution, capacity constraints, looking for potential issues such as reliability problems or even harmonics. Well, these are all possible if you have the digital file, which is the one-line diagram or one-line model in EasyPower. Well, if you are the person that's originated or originally constructed the one line, you probably know every inch and every element like the back of your hand. However, if you're the person who comes in fresh without the benefit of the depth of knowledge from the original engineering group, it can be challenging to comprehend the relevance or even find certain pieces of equipment on the one line. And so to that end, EasyPower has features built into it in the form of easy controls, name views. It's possible to do some organization with color segmentation, having some coordinated labeling scheme where by the name, because each device is required to have a unique ID, have a scheme worked out where the device can be found based upon the information that's contained in the label itself. And then, custom drawing templates and custom panels and MCC templates are all features to help improve the utility and productivity of the one-line diagram itself. I'm going to focus primarily on easy controls on the name views. Before I get there, I want to emphasize, especially on your first project, but more so on even subsequent projects if they're intended to be or expected to be very large, and that is start with a very small representation of the one line and the devices in it, from the utility in connection all the way down to the last device in a particular panel or motor control center that needs to be labeled, and then make sure you can produce the results and that you're looking for. And this includes the short circuit results and the arc flash results, in part to make sure you understand the mechanics of the tool, but secondarily to realize or to understand the need at some subsequent point of finding those elements, especially if you have a large one-line diagram. And so this is not something that has hard and fast rules. I get reports of where people have tried and retried again to orient their organization such that it could be found and more easily utilized. And in fact, the example I'm going to show, I got permission from the University of Wyoming to use his idea because it's a very clever organization of the one line. And so again, whatever we come up with as far as the scheme and the organizational technique, you really do want to document as much, making sure that you adhere to that scheme as you develop the one line, but also for someone that's coming in later to be able to understand your thought process as they're trying to pick up the project and get results out of it. So this may be a little tough to see on the screen, but this was a copy of a file that I just received in the last couple of weeks. And it was exactly that. The engineer that was picking up the project for analyzing and potentially adding some additional capacity to the system was just presented with the one line without any real contact with the person that did the work. So let me kind of start there, and we can talk about this. So here's what the file looks like. Now, normally, as I mentioned, I'm going to be talking about easy controls and the name view elements, but it's obvious if I look at these. In fact, there was no name view on in the original project. I think I've added a couple just to kind of see what could be done. And the problem is when the one line is already drawn, it's difficult to segregate out subsystems or sections and then isolate them because you have all these interconnections that need to be drug around at the time. So the originator used colors for some scheme, some part of his scheme. The other thing that becomes obvious once you try to locate certain elements is that he has or she has labeled things in such a way that they have a specific meaning and help understanding what we're looking for. So even though he has 98 transformers, they're named in such a way that they have some relevance on the location or the part of the system. And so to be able to find that makes it relatively easy without a lot of scanning around based upon, in particular, a legend that tells me what the function of that particular part is. So this could be done as far as unique labeling for things like buses or loads. He's done a good job on the bus nomenclature. And so this would make it relatively easy to jump around in the system and learn, if you will, kind of the organizational scheme that he developed. So I don't really have a problem with this as long as it has been documented, so I can carry on that process as I add additional devices. So again, not anything bad to say about this. It would be difficult just because of the interconnection involved to redraw this as far as trying to organize it with some other scheme in mind. What I would like to get into more detail on, and probably where I want to spend most of the time right now, is to talk about, as I mentioned, a university campus organization where ultimately it is a very large one-line diagram. And again, this was the result of trial and error. But in this case, the campus had a medium voltage ring where I think it's 13.8 kV that's routed around the campus. And then from that, each building has tapped off through a transformer and then has its own distribution system down below. Now, how this pertains to EasyPower and in the scheme that was evolved over time is the fact that if we want everything on the one-line diagram, and we do, then we have to have everything on the same page, if you will, in EasyPower. But the originator of this scheme envisioned frames for each that he'd locate each building as he fleshed it out with the details and located them in a grid-like fashion on his one line, but it allows him to use easy controls and the named view capability then to be able to jump to different sections of this one-line diagram without a lot of scrolling and panning. And the way he did, or they did this, in fact, it was a he in this particular case, is start with his, as I mentioned, the ring, and then as he added the transformer, and I want to make sure I have a cable involved because that's what's going to stretch, if you will, to where it's located. We've already put the name panel in here for this campus building, so I'm going to relocate the distribution transformer thusly, and then I'm going to add the rest of my system now in this frame, which I will save as a named view. Now in this case, we've developed the generic distribution system that the campus uses in several places as a template and saved it under the subsystems. And if I bring it up, I can find that here's my mailer hall subsystem. And as I insert it, I can bring it over here. Oops. Bring it over here and hook it up to my my bus that I pulled down. Now the significance here is that to avoid a bunch of spaghetti on my system, in my system, as I cross-connect all these different buildings, is I open up this particular cables connection, and I use this icon, this checkbox here at the top right-hand side that says Show Entire Line. I don't want to show it, and when I do that, when I uncheck that box, it stubs off that cable and tells me where it goes to in other parts of my one line. And now that I've kind of got my system developed, I want to save this particular frame as the mailer hall. So under name views, I'm going to create a new mailer hall location. And now as I save that, I can jump around my system now with a fair amount of alacrity and know that it's all interconnected. Now, the significance there, because we do have it on one line diagram, now I can go back to my analytical analysis short circuit, for instance, and as long as my one line is complete, I can go and look at the half cycle current at every part of my system and tell that I'm I'm under control or not. And again, this would be a nice way to analyze capacity issues if we were adding capacity. And so I can jump back and forth to different parts of my system and see the effect while it's all taking place in a short circuit analysis that involves the whole system. Likewise, if I want to do arc flash, I can calculate that and feel fairly confident that the whole system is being analyzed at the same time. Now, one side note, because these go through some pretty hefty transformers in isolation, it is possible with the process of equivalization to make an equivalent circuit upstream from my my transformer. And in fact, it would be looking something like this. If I go back to my Mailer Hall and I fault this bus and look at the current, with that single bus faulted, looking at my high voltage and low voltage report at a half cycle, I could develop individual one lines that have an equivalent supply, equivalent position in terms of the information I get right here, which is my available short circuit current, my X over R values for that particular bus. And again, what this would allow me to do is develop 10 or 11 different one-line diagrams for each building, and instead of having this connection to the ring, have this be a transformer, a utility icon that would give me the equivalent of the short circuit available current at this particular point. The downside with doing that, I mean, it would make it convenient as far as drawing simplified one lines. It would be, there's trade-offs involved. If I were trying to limit my bus count, that's one way to do it. If I expect to do additional analysis like load flow and harmonics, it would not be as useful because it doesn't represent the actual connection to the rest of the system. It's just an equivalent short circuit connection. So anyway, I think that pretty much covers what I was trying to highlight today. The fact that in easy controls, we have the ability to jump around the system that's been properly laid out and see the relevant results. Likewise, with this kind of connection, I can go into power flow and do the same type of analysis or do the same type of, I guess, value added evaluation of my system. And so I guess I don't have any loads in these MCCs. But now this gives me my load flow for the whole system, and this could be used in dynamic stability if I want to see the impact of any part of this subsystem and how it impacts the rest of my layout. Okay, that was kind of short and sweet today. Appreciate you all attending. Let me go back and again, I invite you to join us in 2 weeks. Well, actually, yeah, in 2 weeks we'll have another webinar that I think is the 10 most common mistakes made in ground fault and arc flash calculations. Let me check to see if there's any vital questions that could be answered. And if not, we will talk to you next week. Thank you very much for, oh yeah, there are some questions. There's a good question. Notice from the past experience that the voltage drop across a transformer is 3 to 5%. Excellent question. And I chuckle because it's one of my favorite my favorite examples in talking about power flow. And the case in point is, let's say if I have, so I'm in power flow right now, and I'm looking at the, and obviously I don't have any loads. Let me go find, I have a little bit of load. If I can look at the voltage drops, I'm looking here at a voltage drop of 0.59%, which is not bad, and it doesn't amount to the differences that you're talking about. But let me use this to show the technique that I think is a clever way to do this. The issue ends up being, if I go back to the database edit and look at the two-winding transformer dialog box, when we set up the information for this transformer, we normally tap it at the same ratio that we have for the voltage. And so this is assuming a perfect transfer of current across the turns. If we put 13.8 in, we get 0.48 out, kilovolts. Well, if that's not the case, if our load is such that we have a greater, and let's just add a load here to do this. Database, let's say add a large motor. And I'm not concerned about controlling it. I just want to put a lot of load on here and see what happens. Let's say this is 500 horsepower. And we're going to be evaluating it at 100%. So if I come in here and solve, now I see a drop across the transformer of 2.9%, and I don't want that. So here's what I'm going to do. What I want to do is determine what the tap needs to be on the transformer to hold the voltage at the desired level at a minimum point. So instead of making this a fixed ratio, I'm going to go and set up, okay, what if this had a load tap changer, and I want to change it, the tap on the from side, and I want to control it on the to side. So it's going to lock into 0.48 and then make an adjustment on whatever the input voltage needs to be to minimize that voltage drop. So now that I've got that set up for my, even though doesn't have a load tap changer on it, it's going to solve a quiescence. The tool will solve a quiescence and make those adjustments. So now as I can control this drop. We're seeing there's actually a boost of 1.57%, and it's because we tapped this transformer at 13.2 to get a 0.48 out of it. And now as I go back to my database edit and look at the transformer, now we can see that I want to change this tap now to whatever that number was, 13.7. Let me go back and check. You got to have a memory to work on this stuff. Yeah, so I need 13.21. All right, so if I go back now to my database and change my tap on the transformer to 13.21, and then take the load tap changer out of it. Now when I go back to my power flow calculations and solve, again I get a boost at the current range of 1.5%, but it gives me very close to a 0.995 per unit voltage on the output. Anyway, so that's one way to get there. The made changes to one line, the name view pointed to the old location. Kay. Kay's saying that she has an issue with pointing to the old location, and that's a good question. And she's saying that when she made changes to the one line, the old location needed to be recreated. Again, that's the recommendation to do trial and error. So let me see if I can recreate what, well, I just added this to Yeah, see, this is the one line. This isn't, name view doesn't have anything to do with anything else. I think you're talking about drawings, okay? And that could be, yes, there could be some issue if I'm making changes on the one line that don't necessarily reflect to the drawing. But I'm not talking about that, and I appreciate that feedback. I probably need to do a presentation on that. What I'm talking about is the name view. The name view has nothing to do with the one-line diagram. It has to do with pan and zoom settings for this particular screenshot. And so when I change this element, I'm changing it on the one line, absolutely. Now, if I save this, and Kay's talking about, if I left click and drag and select, let's say, everything in Sproul Hall, I can go into my drawings, create a new drawing, and let's just leave it drawing what it is. And she's saying that when she made changes here, and that's exactly what we're seeing. So on my one line, I added a motor, and it hasn't reflected it on the drawing that I saved with the system. Now, with that said, let's try it the other way around. Let's add a motor here, and apologize for, yeah. And that, so now we got to say, be careful, you don't want to do this in the drawings. So Kate, you made a valid point, and the bottom line is, if you're going to use drawings and you make changes to the one line, you need to delete and recreate the drawing inset. That recommendation doesn't apply to name views. Another question. Normally we produce SLDs, recorded deliverables per area. I like the ring topology. Yeah, and so the recommendation is you can use the same technique for doing floors when you have a facility with multiple floors. Now, with that said, let me kind of go back to my, with that said, the tool allows me to, when I come in and look at the buses, I can create a location that includes both the XY coordinates and the floor. So there are ways to segregate the drawing that way, and it still may not be as good as this as far as the visual representation. Okay, appreciate the questions. It looks like I've stomped all over a few of them. And if you have any other questions, I think, John, you asked the question, the difference between drawings and name views, and I think Kay just pointed it out to us. Name views will keep up with changes because it is the one-line diagram, whereas drawings are a snapshot, and if I make changes to the one line, I need to recreate the drawing that's being saved. Okay, you guys did a good job of making this a lot more interesting, so I appreciate the input. Any other questions, you're more than welcome to give me a call or send me an email, and I look forward to talking to everyone down the road. Have a good day.